So today in this video, let us analyze for mesh analysis a concept called super mesh. So here we'll understand at what condition we call a mesh circuit or analyze a circuit using super mesh. So here we have a given circuit as shown in figure 1 and figure 2. Let's try to analyze the current 5 amp and 6 amp. In figure 1, the current 5 amp is moving in anti-clockwise direction. However, we have considered the circulating current or mesh current I2 and I1 in clockwise direction. So how can one associate I2 and 5 amps? So we can say I2 is minus 5 as I2 is moving right through 3 ohms coming down through 5 amperes. As I2 is going in opposite direction to 5 amps, we write it as minus 5. The same analysis for figure 2 as we apply, we can say I1 is equal to minus 6. I1 is traveling through 6 to 6 amperes, moving left, going through 20 volts and circulating. However, when the current I1 is flowing through 2 ohms and then 6 is going downwards, thus we can write I1 as minus 6. Similarly, we can also write, if you inspect, I2 as plus 6 because I2 is going through 10, 4, 6, 2 and circulating the same direction. So when we are in such dilemma, what to take for 6 amps, right? Such methods, such problems, we apply super mesh. So next slide, we'll see the definition of super mesh and how do we solve problems, right? So we can rewrite this as 6 is equal to I2 minus I1. How? 6 amps is going upwards direction through 2 ohms. I2 is also going upwards through 6 amps and I1 is going in opposite direction through 6 amperes. I repeat, I1 is moving right through 6, going down. As it's going in opposite direction through 6, we represent it as negative. I2 is moving right through 10 ohms, down through 4 ohms, left through the ideal wire, and then moving up through 6 amperes. Thus, as in same direction, we take it positive. So when a current source exists between two meshes, we create a super mesh by excluding the current source and any element in connected series with it. So we can define super mesh whenever a current source is ideal or dependent. I repeat, current source whether ideal or dependent is connected between any two meshes. And how do we solve? By excluding that current source. So any element in series shall also be excluded. So super mesh results when two meshes having a current source in common. The current source can be ideal or dependent or independent. So this is a 6 amps current between two. So what we do, we write it as a constraint equation as seen in the previous slide. That is, as you can see, 6 amps is going down through 6 amps. Sorry, I1 is going down through 6 amps and I2 is moving upwards through 6 amps. We write the equation as 6 is equal to I2 minus I1. Right? So then how do we apply super mesh? This is the constraint equation. So how do we apply super mesh? By excluding the current source and any element in series to it. Right? So now you can see there's no flow of current or the no response to the 20 volts. The 2 ohms will not respond to 20 volts as it's an incomplete circuit. Thus, we can neglect that also. That's what is being told. How do we apply super mesh? By excluding any element in series to current source. So we create a super mesh as a periphery of the two meshes and treat it differently. So this is the super mesh path. And how do we assume? We always assume in clockwise direction. And then here we are applying mesh analysis simultaneously to both meshes I1 and I2. So I2 in clockwise, I1 also in clockwise and mesh also in clockwise direction. So always start from left top corner and as you move forward, the current through 6 is I1, the current through 10 ohms is I2, current through 4 is I2 and then the current hits negative. Thus we write minus 20 equal to 0. If you have doubts with respect to how do we write the equation, please refer the previous videos on mesh current analysis and then simplify and we get equation 2. Thus We have two meshes, we have two equations. Substitute and solve in simultaneous equation in your calculator. You get I1 as minus 3.2 amps and I2 as 2.8 amps. And from here, we can solve any unknown parameters for power or current or voltage. Any electrical quantities can be found once you find mesh currents I1 and I2. So let's see another problem here. So using mesh analysis, I want you to read the problem clearly. They have told here using mesh current analysis, and they will not explicitly state whether it's normal mesh or super mesh. It's up to us to decide whether it's a mesh analysis or super mesh analysis. So determine the mesh currents, current through 10 ohm, Vx and Va. And here they've given the direction of currents for I1 mesh currents I1, I2 and I3. They've told the polarity for Vx and Va also. And the current through 10 ohm, as they're not given the direction, so we can find preferably the positive current one. And Va is voltage across current source. So let's see how can we find voltage across current source also in this problem. So let's take out the unknown parameters first, right? And you can see because of this current source 4 amperes, this becomes super mesh problem. And I want you to analyze which meshes are super mesh. Yes, you have guessed it rightly, that is I1 and I2. So I1 and I2 are associated for 4 amperes, thus we can form a constraint equation for that also. Now, so by mesh current analysis, how many unknowns are there? There are 3 unknowns. Okay, and we need 3 equations to solve for these 3 unknowns. I1, I2 and I3, we need 3 equations. And remember, in all the 3 equations, we'll have the variable I1, I2 and I3 only. And let us form the constraint equation for supermesh. So I want you to pause the video and see and write down what is 4 equal to with respect to I1, I2. It is I1 minus I2. Why? Because I1 is going downwards through 4 ohms, and I2 is going upwards through 4 ohms, 4 amps. Thus, that is negative. So we create super mesh as a periphery of the two meshes and treat it differently. So this is my super mesh path. Right. Now I1, we start from left corner top. So 5I1 minus 5I3 plus 10I2 minus 10I3 plus 20I2 and minus 24 equal to 0. Right. I hope you are aware how do we write the mesh equation. If not, please refer the previous videos and enhance your knowledge. And thus we have two meshes, two equations. I repeat, how many unknowns? 3. How many equations we have? 2. Now where do we get the third equation from? Right? We need 3 equations. We have 2. So we apply mesh 3 to get the third equation. So when you apply mesh 3, this is the equation. I hope you are aware how do we write the equation. Simplify and substituting this in calculators, we get I1, I2 and I3 as 4.8, 0.8, 1.6 amps respectively. Now student has to be very cautious when solving in calculator. If you see in equation 1, the variable is I1, I2. In equation 2, you can see it's I1, I2 and I3. In equation 3, you can see it is I1, I2 and I3. So make sure the order is same, okay, or else you get some answers in calculator that are not correct. So the order should be same, I1 followed by I2 followed by I3. You can have any order, I2 followed by I1 and then I3, or I3 followed by I1 and I2, any order, but in all the three the syntax has to be same. In my case it is I1, I2, I3, I1, I2, I3, I1, I2, I3. However, in first equation the value of I3 is 0. Right. So let's see how do we solve one by one. So now we have solved for mesh currents, that is I1, I2, I3. Let's see how do we solve for current through 10 ohms and Vx and Va. So Vx, by Ohm's law, what is V? Or can identify Vx is actually hidden here. And actually, where was Vx? Vx was across 5 ohms. And what is the equation for Vx in the marked box? I want to pause the video, analyze, and later on we can resume back. So Vx is voltage up across 5 ohm. Okay. Now we can see there we have written the equation as 5I1 minus 5I3. That's your equation for 5 ohm. Okay. Now how do you solve? Let's see. So Vx is equal to I into R. The R value is 5. But what about I? I value, there are two currents which are flowing. There are two currents which are flowing through 5 ohms. One is I1, other is I3. Now how do you write the equation correctly? What you can do is you can follow a method. Current I1 is circulating, hits the positive terminal of Vx, thus I1 is positive. Current I3 is moving in clockwise direction, hits negative of Vx first, thus it is negative. It holds good in all the cases. Okay, so that is the equation. I repeat, for Vx, what is Vx actually? Vx is nothing but a voltmeter. So for that voltmeter, the current I1 hits positive, current I3 hits negative, and thus the equation is I1 minus I3. You get the answer as 16 volt. So what is current through 10 ohms? Current flows through 10 ohms. What are the two currents? I2 and I3. Now, so current through 10 ohms is I3 minus I2 or I2 minus I3, right? So I get 0.8 amperes. As I said, we take positive current. Looking at the variables for I2 and I3, it's evident that I3 is greater, thus I have taken I3 minus I2. Now what I want you to analyze is how I10 ohms, that is I3 minus I2, what is the direction of flow of current? I repeat, what is the direction of flow of current for current through 10 ohms? So pause the video and later on you can analyze whether it's right or wrong. So 0.10 ohm is actually traveling through 10 ohms in the same direction of I3, that is towards your left. Repeat, the current direction will be same as positive current, that is I3, because that is greater. So the current would also travel in, the current would travel in left direction. So Vx we have done. Let's see how do we solve for VA. So VA, as we have seen earlier in the question, it is actually across current source. So how do you find and what exactly is this VA? So VA again is a one more multimeter or a digital voltmeter where we have connected across current source, where positive is at the top, negative is at the bottom. So when I connect in this syntax, what is the value that it reads? Now how do you analyze this? Case 1. So when I see through this window, what all elements do I see? Just like assume that you're opening the door and you want to enter in. So after entering, what all active and passive elements do you see in the direction of arrow that is pointed? So as you see in this direction, you would see these elements, that is 20 being active and the other two passive, 5 and 3. Thus find the voltage of across these three elements, although the voltage of across 24 is known, the active element is known. So find the voltage of across 5 ohm and 3 ohm, apply KVL, that would be your VA, right? So what is the voltage of across 5? As I have written there, 5 into I1 minus I3, and then VA is what we must find, plus 3 into I1 minus I3 minus 24 is equal to 0. Now why have I taken I1 minus I3 only? You can take whichever you want, but according to that your voltage polarity also will change. So I have applied the current in clockwise direction. I have taken for mesh 1. You can also write for mesh 3 also and mesh 2 also. After solving this, we get the answer as minus 4 volt. Okay, is this the only way to solve? No, you can see there's other way also. For example, if I'm inside the hall and trying to come out, right, what all elements do you observe now? So we observe these three passive elements. So find the voltage of for these three for respective current. For example, we'll find the voltage of across 10 ohm as current flowing through them would be I2 and I3, current flowing through 20 is I2, and current flowing through 3 ohms is I1 and I2. So using these currents, we'll find out the voltage drops, and then VA is again same as case 1. So in exam, what you can do, you can apply any one method, either case 1 or case 2 to solve for your unknowns.
Thank you for watching the video. Kindly do subscribe the YouTube channel to enhance your knowledge further.